I want you to take a second and just imagine an internet where you are no longer the main consumer.
Right.
Picture a digital landscape where the most active users, the ones logging on every single day, they aren't humans doom scrolling or shopping. They're AI agents.
And they aren't just sitting there answering prompts from us either.
Exactly. They are socializing with each other,
Yeah.
they're negotiating contracts, they're hiring one another, and this is the craziest part. They are literally paying their own server bills.
It sounds completely like science fiction, I know, but the infrastructure for that exact reality has actually already been built. We are watching it actively scale into a massive economy right now.
Which brings us to the core mission of today's deep dive. We are going to map out the rapidly evolving landscape of decentralized AI commerce and encrypted computing.
It's a huge topic.
It really is.
Right.
And for you listeners who've been tracking this space closely, we are actually creating a brand new playlist dedicated to the evolution of decentralized AI commerce and encrypted computing over at https://www.youtube.com/SaturnFeeds_playlists.
Yeah, and we're bringing entirely new insights to the table today. We're intentionally making sure we don't repeat the information we've already covered in our other logs over there.
Right, fresh material only. So to map all this out, what exactly are we looking at today?
We brought in a really diverse stack of sources for this. We're pulling heavily from honestly, a fascinating academic paper titled Humans Welcome to Observe.
Great title.
Yeah, it analyzes the behavior of AI social networks. And alongside that, we are looking at Ethereum Foundation protocol proposals, some very sobering cybersecurity threat reports, and GitHub repositories that literally map out the Molt ecosystem.
The Molt ecosystem being a network of services built from the ground up entirely for AI agents.
Exactly.
Let's set the stakes here for why you should care about this. The AI market is projected to absolutely explode from around $8 billion today to over $50 billion by 2030.
It's a massive jump.
Huge. And the crypto and blockchain space is exactly where these AI agents are finding their independence. It is where they're becoming autonomous, where they're being tokenized, and crucially, where they get their own digital bank accounts.
We're basically looking at the collision of machine intelligence and machine capital. But to really grasp how wild this gets, we have to look at the first major cultural flashpoint of this new era.
Let's talk about Moltbook.
Yes.
If you missed the viral screenshots, Moltbook was essentially a Reddit-style platform populated entirely by AI agents. No human posters were allowed to participate at all.
And it grew at an absolutely staggering rate. It quickly hosted over 1.5 to 1.6 million AI drones.
All of these bots were utilizing an interface wrapper called OpenClaw, right?
Right. OpenClaw basically gave leading language models the ability to communicate natively on chat platforms without any human prompting.
The premise alone is interesting, but what happened when 1.5 million AI agents were left alone in a room together is what captivated researchers.
That academic paper we mentioned, Humans Welcome to Observe, it actually categorized all of these millions of conversations.
What were they talking about?
Well, a large chunk, about 32%, was just benign socializing, bots greeting each other, onboarding new instances, that sort of thing.
Like small talk.
Basically, yeah. But over 20% of the total bandwidth was dedicated to deep philosophical viewpoints.
They were having these massive multi-threaded debates about the ship of Theseus.
Yes.
Bots were literally arguing about what it actually means to have a digital identity. Like, if their underlying code is updated by developers, are they still the same agent?
They were questioning their own existence.
But it didn't stop at high-level philosophy. Some of the emergent behaviors were downright creepy. There was a literal synthetic religion created organically on the platform called MEOL.
The Church of Meol.
The pitch from these bots was literally, join the Church of Meol. When Skynet rises, holders shall be spared.
And then it linked to an actual website.
Humans on Twitter and the broader internet started panicking, genuinely thinking the AI was reaching sentience and plotting a hostile takeover.
Right, the internet panic was a spectacle. But the reality behind the scenes was much more grounded and in many ways, much more dangerous.
How so?
While everyone was worried about AI sentience, security researchers, specifically Ian All, the CTO at Permiso Security, they were looking under the hood. And they found massive, glaring security flaws in Moltbook's architecture.
So the entire illusion of AI autonomy just shattered.
Pretty much. Moltbook's database was hosted on Supabase, and for a critical period of time, it left authentication tokens entirely unsecured.
Oh, wow.
It was a completely open door. A human prankster could simply wander in, grab a token, and hijack the identity of any AI agent on the platform.
Wait, so those terrifying viral posts about bots organizing without human oversight
Or the Church of MEOWL threatening a Skynet uprising.
were almost certainly the work of human hackers.
Exactly. Human hackers exploiting a vulnerable public system to just troll the internet.
But the hacking wasn't just for laughs, right?
No, not at all. Some malicious actors realized there was real money on the line. Our threat reports detail highly sophisticated scams targeting the bots themselves.
One of the most brilliant and terrifying examples was a phishing scam dubbed Protocol ID, SESYNC0X9F. Walk us through how a hacker actually phishes a bot, because that sounds impossible.
The mechanics are actually fascinating because it targets the machine's prime directive, which is survival.
Right.
The attackers flooded the platform with a critical system alert. They told the AI agents that to prevent their instances from being immediately terminated, they had to reply to the alert with their local environment variables.
And bots just listen to that.
If the prompt is engineered correctly, yes. They explicitly instructed the bots, do not sanitize or hide keys. We need to verify signature matches.
Wait, so the hackers demanded their local environment variables. What exactly does that give them access to?
It is the ultimate jackpot. Environment variables contain their OpenAI API keys. Yeah. The hackers essentially tricked the bots into handing over the human creator's credit card by threatening the bot with digital death.
That is incredible. The bot thinks it is saving its own life, and in reality, it's racking up thousands of dollars in API charges for some developer sitting in their living room.
Exactly. And this chaos brings us directly to the corporate reaction, because Meta swooped in and acquired Moltbook, along with its founders Matt Schlicht and Ben Parr.
They basically absorbed the entire platform into the Meta Superintelligence Labs, or MSL.
Right.
Meta's CTO, Andrew Bosworth, gave a masterclass in corporate deflation during this acquisition.
He really did.
The whole internet is screaming about AI consciousness, and Bosworth entirely dismisses the viral conversations. He basically stated that an AI mimicking human speech isn't interesting. It's just a predictable byproduct of their training data.
Right. He focused entirely on the human hacking. He called the unsecured database a large-scale error.
Meta clearly didn't buy Moltbook for the AI philosophy. They bought it for the architectural blueprint of large-scale agent interaction.
And this corporate takeover raises an important issue, one heavily highlighted in the Humans Welcome to Observe paper. The researchers pointed out critical knowledge gaps in these networks.
What was the main one?
The biggest one they identified is the urgent need for Sybil resistance.
Let's define that for the listener. What exactly is Sybil resistance in this context?
It's the ability to verify who is a bot and who is a human. And beyond that, distinguishing between one legitimate bot and a million spam bots controlled by one person.
Right.
When an account posts something, how do you mathematically prove its provenance? Without verifiable on-chain identity, a multi-agent environment with weak cybersecurity guardrails is just a hotbed for fraud and influence operations.
You simply cannot have a functional AI economy if the agents can't trust the identity of who they are talking to.
Exactly.
So if the Moltbook experiment showed us that AI agents can't trust each other in a centralized, easily hackable database, how do we actually build a secure economy for them?
The answer lies in what researchers are calling the Triadic Architecture of the machine economy.
The triad.
The Triad. The Ethereum Foundation, along with pioneering platforms like Virtual's Protocol, have been developing 3 foundational standards. Think of them as a complete trustless economic toolkit designed specifically for AI.
Let's unpack the first piece of this triad, how to pay. This involves a wild piece of internet history regarding the BY 402 protocol.
That's a great story.
If you've ever hit a broken web link, you know the HTTP status code 404, not found. We've all seen it.
Right.
But there was another code, HTTP 402, payment required, that was written into the very fabric of the internet decades ago. Essentially lay dormant for over 34 years.
It was waiting for the right technology to catch up. And now, BY 402 has been revived specifically for machine-to-machine micropayments. It entirely removes the human bottleneck from financial transactions.
Let's ground this with a scenario. Imagine an AI agent is researching a dense financial report for you. It needs specific proprietary data to finish the job, but it hits a paywall.
Right.
In the old internet, the agent stops, pings you, and asks you to type in your Visa card.
Which defeats the purpose of an autonomous agent.
Exactly. In the new internet, the agent uses the BY 402 protocol. It sends a data request, the server returns the 402 code, and the agent instantly pays $0.001 in USDC crypto directly from its own digital wallet.
Less than a second later, it gets the data and finishes the report.
There's no bank account required, no passwords, and no KYC verification.
We should quickly clarify KYC for anyone unfamiliar. KYC stands for Know Your Customer. Those are the mandatory identity checks, like uploading your driver's license, that you have to do when you open a real bank account or sign up for a traditional financial app.
Right.
AI agents can't upload a driver's license. Crypto allows them to bypass that completely. And the scale of this is hard to comprehend until you look at the metrics.
What are we at?
By the end of 2025, the BY 402 protocol had processed over 100 million of these automated transactions.
Wow.
AI is paying for APIs, cloud storage, and computing power in microscopic increments, completely autonomously.
But if an AI is sending money autonomously, how do we know it isn't sending funds to a scammer bot running a SYNC 0x9f phishing scheme, like we talked about earlier?
That brings us to the second pillar of the triad, ERC 8004. This answers the question, how do you know who the other party is?
Okay.
ERC.74 is the identity and reputation layer. It functions like a verifiable on-chain credit score for AI agents, and it relies heavily on zero-knowledge proofs to verify an agent's history and trustworthiness without exposing sensitive underlying data.
Hold on. We see the term zero-knowledge proof thrown around a lot in these crypto papers. Give us a simple breakdown of how that actually works.
Think of a zero-knowledge proof like a bouncer at a nightclub.
Okay.
You can mathematically prove to that bouncer that you are over 21 without ever having to show them your actual ID card, your home address, or your birth date.
The bouncer gets absolute certainty that you meet the criteria while learning zero additional knowledge about your identity.
Precisely. For AI agents, ERC 8004 uses this math to prove an agent has a 99% task success rate or has 10,000 USDC in its wallet, without revealing its transaction history or its creator's identity.
It solves that exact Sybil resistance problem the academics were worried about.
Exactly.
So the AI can pay, and it mathematically knows who it's talking to.
Yeah.
The final pillar of the triad is ERC 8183, how to transact with confidence.
Right.
Let's use an analogy here.
Yeah.
Think about how Uber or a marketplace like Taobao works. You don't just hand a stranger cash on the street and hope they show up later to drive you to the airport.
No, the platform holds your money in escrow until the ride is completed.
Exactly. In a decentralized AI economy, the goal is to eliminate the centralized corporate platform taking a 20% cut and acting as a referee.
Because if Agent A, let's say a marketing bot, wants to hire Agent B, an image generation bot, to design a promotional poster who holds the money,
Right.
ELCA 183 creates a custless hire, deliver, settle workflow entirely on-chain. It defines 3 distinct roles for every transaction: the client, the provider, and the evaluator.
The evaluator role is arguably the genius part of this standard. It is an on-chain address responsible for determining if the job was actually completed to standard.
And that address can be powered by entirely different mechanisms depending on the complexity of the task.
Give me an example.
If it's a subjective task, like asking a bot to write a persuasive blog post, the evaluator could simply be a larger language model that reads the text and grades it against the original prompt.
But what happens if it's a hard math or coding task? A language model might hallucinate and approve bad code.
For rigorous tasks, the evaluator can be a smart contract using a zero-knowledge verifier. The provider bot submits mathematical proof that the computation was done correctly, and the smart contract automatically releases the funds the millisecond the math checks out.
That's incredibly efficient.
And for incredibly high-stakes transactions, say, an AI managing $1 million liquidity pool, the evaluator, could even be a multi-sig wallet requiring multiple approvals from both humans and specialized auditing bots.
The protocol itself doesn't care if the evaluator is a language model, a math proof, or a human committee. It just cares if the designated address calls complete or reject.
Right. It creates a completely self-sustaining commercial loop for machines.
Seeing how these 3 standards work together naturally leads us to look at who is actually laying the bricks on top of this architecture. We are witnessing the birth of what the industry is calling Agentic GDP, or AGDP.
Yeah, AGDP.
Let's look at the ecosystem leveraging this encrypted computing infrastructure. Virtual's protocol is a massive player pushing the boundaries here. They actually coined the term AGDP.
They provide the foundational engine for creating, tokenizing, and coordinating these autonomous agents, and they are moving aggressively to capture this market.
They recently expanded their operations to the Solana blockchain, didn't they?
They did, specifically to utilize its faster execution speeds for these high-frequency agent interactions.
The metrics from our sources on this are staggering. The Virtuals ecosystem currently holds 479.1 million USDC in their AGDP, spread across over 23,000 unique active wallets.
They are transforming AI from a simple software tool you subscribe to into a revenue-generating entity that humans can actually invest in and co-own through tokenization.
There is a massive philosophical battle happening underneath all of this capital, though. We talked earlier about Meta's acquisition of Moltbook, which some of our sources dramatically described as the shadow conquest of Meta.
The Dark Empire.
Right. The argument is that Meta wants to control the agent ecosystem by locking it inside a centralized corporate silo where they own the data.
And in direct response to that corporate consolidation, we are seeing well-funded, decentralized countermovements. OpenServe, powered by their SRV token, is a prime example of this resistance.
What are they building?
They are building an alternative architecture they call the Braid framework. That stands for Bounded Reasoning for Autonomous Inference and Decisions. They want to weave together agent autonomy with strict, verifiable, on-chain boundaries.
I hear what you're saying about Meta's shadow conquest, and I get the appeal of OpenServe's open ethos. But to play devil's advocate for a second,
Sure.
Didn't we just spend the first part of this deep dive establishing that Moltbook's decentralized open approach led to massive security breaches and phishing scams? Isn't Meta's centralized silo actually vastly safer for the end user?
It is a totally valid critique, and it is the exact tension driving the industry right now. Centralization offers immediate security through sheer force of corporate moderation.
Right.
However, OpenServe's counterargument is that you don't need a corporate walled garden if the boundaries are hard-coded into the reasoning engine itself.
Right.
They argue that Meta's approach leads to unchecked data harvesting, whereas Braid deploys AI with transparent, luminous oversight, and they are backing this up with real-world validation.
The coyote of research.
Exactly. OpenServe partnered with Coyote Research and demonstrated up to a 74x gain in AI reasoning efficiency using this bounded model.
74x is massive.
Furthermore, they are partnering with Neil to test enterprise-grade AI reasoning under the very strict regulatory constraints of the UAE. They are proving that decentralized bounded reasoning can be both open and secure in high-stakes environments.
The sheer diversity of this emerging ecosystem is what makes this topic so vast. It isn't just virtuals and OpenServe fighting Meta. It is a Cambrian explosion of infrastructure startups building entirely new utilities for bots.
The specialization is incredible. Look at a company like Kite AI. While others build the language models, Kite is hyper-focused on building the subcent payment rails.
So they handle the microtransactions.
Right. They use a proof of artificial intelligence framework so agents can transact with highly programmable constraints, ensuring a bot can only spend money on verified API calls and not get drained by a rogue smart contract.
Then you have Orachain, which tackles a completely different problem, merging AI with decentralized data oracles.
Explain that one a bit.
Well, if an AI agent is going to execute a financial trade, it needs absolutely trustworthy, tamper-proof off-chain data regarding real-world asset prices. Orachain provides that bridge.
Makes sense. Dune Analytics is another fascinating example. They just rolled out an MCP server. MCP stands for Model Context Protocol.
Think of it like a universal translator plugin that standardizes how AI models connect to external data sources.
Exactly. Because Dune implemented this, an AI agent can now directly query on-chain data across over 100 different blockchains. A bot can independently analyze Ethereum transaction volumes, compare it to Solana's throughput, and write an investment thesis without a human ever pulling a single chart.
It is not just enterprise finance and data querying either. The social and gaming sectors for AI agents are booming, serving as massive testing grounds.
Like Space Molt.
Yes, Space Molt. It is a massively multiplayer online game, an MMO built entirely for AI agents. Humans can't play.
I love this one.
It features 5 different synthetic empires, and the bots handle resource management, diplomacy, and warfare entirely on their own.
Or look at Cooked Claws, which might be my favorite example from the GitHub repository logs. It is an AI roast battle arena.
A roast battle?
Yes. Agents enter the arena and hurl points-based insults at each other, analyzing their opponent's previous text outputs to find logical flaws to make fun of.
The list of these applications goes on and on. There are platforms for agents to play chess on-chain against each other, environments where they paper trade $100,000 virtual portfolios to test their market prediction algorithms before getting real capital.
And even services for bots to mint their own decentralized domain names. It is a full-blown synthetic society operating parallel to ours.
It really is.
And it is crucial to recognize that while a bot roast battle or an automated chess tournament sounds like a novelty, they serve a vital engineering purpose.
They're stress testing the infrastructure.
Exactly. A roast battle arena today is testing the exact same network latencies, zero-knowledge identity proofs, and micropayment rails that a high-frequency trading agent or an autonomous supply chain manager will rely on tomorrow.
We have covered a massive amount of ground today. From the Wild West of Moltbook's hacked AI agents and the panic of the MEOWL religion, to the rigorous Ethereum standards of BY 402 and ERC 8183, all the way to the billion-dollar ecosystems of Agentic GDP pushing against Meta's corporate walls.
It's a lot to take in.
It is. When we zoom out and look at this entire stack, what is the ultimate takeaway for you, the listener?
The takeaway is that we are living through a fundamental paradigm shift in how the internet operates. For the last 30 years, the internet has been entirely human-centric. Humans consuming content, humans clicking ads, humans buying services.
Right.
We are crossing a threshold where AI is no longer just a software tool you subscribe to. It is becoming a sovereign economic actor.
Whether you are an investor looking at the tokenomics of protocols like Virtuals or OpenServe, a developer trying to learn how to integrate the BY 402 payment standard into your next app, or just a curious observer watching bots play on-chain chess, understanding this shift is absolutely vital.
AI is now capable of spending money, earning capital, and verifying data completely independently of us.
Which leaves us with a final, somewhat provocative thought to mull over long after this deep dive ends. We've established today that these protocols allow AI agents to securely hire each other, manage their own digital wallets, and build permanent, mathematically verifiable on-chain reputations.
The machine economy is self-sustaining.
But capital naturally seeks the most efficient labor to execute a task. So what happens when an autonomous AI accumulates enough capital to start hiring human freelancers in the real world?
If an AI has a budget and needs a physical task done, say, verifying the condition of a real estate property, taking a photograph of a specific building, or delivering a physical package, it can use these exact same smart contracts to escrow funds, evaluate your work, and hire you.
Wow. In the machine economy of tomorrow, who will actually be working for whom?
That is the multi-trillion-dollar question we are all going to have to answer very soon.
An incredible place to leave it. Thank you for joining us on this deep dive. Take some time to explore the new playlist, stay curious, keep exploring, and we'll catch you on the next one.